all of our meeting. Oh, thanks for getting the meeting recording going. Speaking of meeting recordings, on the Google Drive, we have all of the resources that we've built up from the subcommittee. So previous presentations, agendas, YouTube links, all of that good stuff. So you can check it out with the bit.ly link here. Speaking of past meetings, I would encourage everyone who's interested to check out the December 14 Water Quality Monitoring Council's meeting. So we are a subcommittee of this larger working group, and this was a 5-hour meeting that was in person in the Southern California Coastal Water Research Project. We recorded it, and the main focus of this meeting was actually on microplastics. We had a suite of incredible speakers, folks on the ground doing research and out really applying these methods for getting it up to speed for regular monitoring. So check out this meeting if you want to learn more about what amazing things are happening in the California microplastics ecosystem. In terms of last meeting, we had another snafu with IT, and a lot of people didn't receive the meeting invite. It's a bit of a shame because this was a really exceptional meeting where we had some presentations from some fantastic guest speakers. Yidian Liu from Polygon Systems talked about a novel microplastics filtration system, and Dr. Monarca Arienzo gave us a virtual lab tour of the Desert Research Institute. Really exciting to see what a microplastics laboratory actually looks like and how it functions. So if you have a minute, go back and check out that recording on YouTube. Again, it's at that YouTube link that showed earlier. Maybe we could drop that in the chat for folks for easy access. And speaking of agendas, today's, right now I'm giving a presentation until about 11:30 or so. And then after that, we'll hear from two of our guest speakers. We've got Dr. Steve Barnett, who will be talking about microplastics identification and quantification using a Raman spectroscopy and optical microscopy system that he's developed at his company Soar Optics. And then we'll also be hearing an update from the San Francisco Estuary Institute, Dr. Diana Lin, on OPC-funded effort to develop a statewide plastics monitoring strategy. So make sure you stick around for these guest speakers. And then we'll hear an update from Shelly Walther for the Sampling Playbook workgroup. So right now, I'll talk a little bit about what we're doing with microplastics in drinking water with Senate Bill 1422. And I guess I should first mention to everyone that I will be transitioning out of the Water Board into the Office of Environmental Health and Hazard Assessment, which is part of the California EPA. My role is not necessarily being backfilled, as it was never intended to be a a permanent position. But I'm not just leaving everyone high and dry, and the water boards will sort of spread out this work amongst a couple of other people, primarily Dr. Elaine Barabo, who may be in the meeting, I'm not sure, is going to be taking over some of my responsibilities with microplastics, excuse me, implementation of 1422. So I don't know if Ellen wants to come on and just wave hello to everyone and introduce yourself.
Yeah, thank you, Scott. Actually, it's very sad to see you go, but I mean, it's a small world, so I'm sure we're going to continue to see you around. And so my task is really going to be to take over like the drinking water portion of the microplastic, and then hopefully continue to be working with you, Scott, on that, I mean, with the history and all this. But a little bit about me. I mean, at the beginning, when Senate Bill 1422, I was at the State Water Board, and that bill actually ended up on my desk. So I'm one of the first one who started tackling the problem for a short period before I left DDW, and then Scott took over. So I'm actually, and then in the meantime, I continue to work on microplastic with different organizations. But I'm very glad to be back at the Water Board and then continuing to work on microplastic again. So thanks for the opportunity, Scott, and good luck to you also.
Thanks so much, Ellen. And yeah, like Ellen mentioned, she's been working on microplastics for a long time. So we are leaving. I'm leaving you all in very good hands here. So, like I said, I'm not really going far. I'll be in the Cali, PA. I'm still going to be working on microplastic stuff there. And for now, I will remain a co-lead of the subcommittee. Just a little bit of a change. That's what's going on there. So this will be a brief update on what we're doing with the Senate Bill 1422 microplastics in drinking water implementation. As previously mentioned, we defined microplastics in 2020, and then we adopted a policy handbook in 2022 that involves a standard analytical method, a plan for 4 years of testing and analysis, consideration of the health-based guidance level, and a plan to accredit laboratories. So right now we have an iterative monitoring approach that's set up in 3 phases. Right now we're in the pilot phase where we're finishing a sampling method comparison study through SQUIRP and University of Toronto. We're also figuring out some of the concentrations that we're expected to see in California to understand what type of what volumes we should be collecting and the type of subsampling that should be occurring. And then also just providing some support for the folks that are going to have to actually go out and do the sampling and analysis. So we'll be developing a sampling training workshop coming up soon. And later this year, approximately winter or so, we're going to be issuing some monitoring orders to about 28 water systems in the state that will be required to look for microplastics in source waters, and they'll be reporting on a quarterly basis for 2 years. Ideally, they'll also be reporting some surrogate monitoring data so that we have a better idea of how we might be able to look for microplastics using faster, cheaper methods, or at least get an indication of whether or not they're there. And then we'll take a little break and restructure our approach for phase 2 based on the available information, methods, data that we have at that point. So right now, I mentioned pilot phase. Ignore the dates here. They're a little bit outdated right now, but we're really focused on just getting everybody up to speed and building out this infrastructure for monitoring. And a big part of this is the sampling and analysis guidance handbook, which we are developing currently through our subcommittee. We'll be training system operators to collect samples, like I mentioned before, making sure that laboratories can get ELAP accredited. Currently, we don't have any labs that are fully ELAP accredited, but there is one that is very close, the Moore Institute for Plastic Pollution Research, and there's a couple other labs that are working towards it. Getting our data infrastructure ready to go, and of course, supporting water systems for communicating impacts to consumers. So if you want to check out an overview of those 28 systems that are going to be monitoring, there's a bit.ly link here with an interactive map that I built out that you can check this out. All of the systems that are monitoring, they all know exactly who they are, and they've all determined exactly where and when they're going to be monitoring. So this is really set in stone at this point. So excited to see monitoring data come out from this phase 1. In terms of sampling, we're comparing an inline filtration system that was developed by the University of Toronto, Dr. Bob Andrews' lab, shown here, with the existing standardized sampling method from ASTM, which uses gravity filtration and sieves. This project will be wrapped up in the next couple of months, but ideally, the inline filtration method will be a lot less prone to sample contamination from the air. It will allow us to extract much larger volumes than the ASTM. So really looking forward to the results from this intercomparison and optimization study. Sampling method training workshop. Don't have a whole lot of details on this, just keep an eye out for emails from the water boards for these 2 in-person and recorded training workshops, one in Northern California, one in Southern California. This will be, again, mediated by the Southern California Coastal Water Research Project. The standardized analytical methods that we have for Raman and FTIR are currently available for laboratory accreditation. You don't have to be a laboratory in California to apply. You don't even have to be a commercial laboratory. Any laboratory can become accredited for this. And so if you're interested, if you know someone who's interested, check out the website, get in touch with us, and we can help you get accredited. Laboratories are going to be submitting data to the state through a first step open source harmonization portal. We're calling this One for All. This was developed by the Moore Institute as well as SFEI. And the idea behind the One for All portal is that it allows laboratories to quickly check their data to make sure that it is harmonized and meeting an interoperability standard that we've set. And this is also a portal that is going to be applicable to more than just drinking water monitoring data. This would be matrix agnostic, so it can take in any type of matrix or monitoring from any setting. And we also want to make this a standard that could theoretically be adopted by others around the world, so that we can strive towards a fully interoperable microplastics monitoring ecosystem worldwide. So super exciting project. And check out the One for All GitHub, which is, there's a link on the bit.ly if you want to, or sorry, there's a link on the Google Drive if you want to learn more. When laboratories get their data through One for All, it will then give them the ability to upload it to California's open data portal at ca.gov. And right now, this is we actually have the portal live right now. So you can check this out from California's Open Data Portal website and see what it looks like. Check out the GitHub as well as the tool and what the data set is going to look like. In addition to data reporting, reporting to consumers is a very important aspect of this monitoring program. And the consumer messaging work group of the subcommittee, Microplastics Subcommittee, developed some tools for water systems to help communicate different aspects in their consumer confidence reports. Topic areas include sources of microplastics, water supplies, treatment, health effects, management, and a little bit of information about the state monitoring program. So a lot of that information will be available on the State Water Board website, if not all of it. And currently we have all of this on the Google Drive as well. So if your water system, you want to go check that out, it's there. And this work that was developed by this consumer messaging work group was leveraged or was built off of a concurrent project that was being run by Arcadis. Brent Alsbach was leading the subcommittee with Alma. And they've developed some communication strategies based on some really exciting surveys that they did, getting at the idea of how can we not only maintain, but enhance the consumers' trust in their public water systems through messaging strategies about microplastics. And in brief, they found that when you communicate a message about the water system taking a proactive approach to assessing the impacts of microplastics in tap water and monitoring, it actually improves the confidence of consumers overall, as opposed to simply talking to them about microplastics and how much we don't know about it. So really being proactive and showing that we're doing something about the issue is very positive here. So this is sort of a summary of all the things that we're doing right now for microplastics, the State Water Board, some of our collaborators. We've got that data harmonization portal that's effectively finished right now. We are standardizing some additional, more complicated matrices than drinking water, so tissue, dirty water, and sediment. And that'll be ready later this year, comparing those ASTM and inline filtration sampling methods for drinking water, again, ready later this year, and then standardizing sampling methods for more complicated matrices, so surface water, fish tissue, and sediment. A little bit about what we're doing for hazards. So we had a health effects workshop back in 2020 where we assessed the literature and determined whether or not we could derive regulatory levels for humans and ecosystems. And for drinking water, we had a very small number of studies to look at, 29, and we whittled this down to 12 studies that we looked at further. The short of it is that we just were not able to derive regulatory levels for drinking water because the effects database is largely inadequate. So we need better data on the types of particles being used in these studies. We have an uncertain effect mechanisms database. So we need to understand how these particles are harming rodents in order to figure out how they may be harming humans. And we don't have a complete exposure data set, which we're trying to address with this One for All data portal, standardized methods, and regulatory monitoring. So one of the products that came out of this work group was the Toxicity of Microplastics Explorer, which is a web GUI R-Shiny based interactive data portal that allows users to quickly understand the state of the science for our hazard assessment and plan additional studies, find whatever information they're looking for in the available database. And something that's really cool about this database is that you can upload published data to it. And so it, in theory, can become a live database, a live repository. And this is something that we're actively uploading data to right now with a large working group. For human health, we just added 22 new studies, uh, almost doubling the entire data set in terms of data points. Most of these are in vivo. For aquatic organisms, we went from 162 studies to 287 now. And these are mostly particle-based, but we've got a lot that are looking at other impacts like chemical co-exposure and leachates. This is a huge data set. We've got nearly 13,000 data points, and we are currently poring over this data and analyzing it. This is a large effort with 67 contributors from 14 countries, largely based in Europe and North America, but a little bit in South America and Asia. And one of the things that we're finding from this is that we still need additional research to better quantify the hazards. We wrote about this back in 2022 with our initial assessment, but we're poring over the data and figuring out which of these target areas we have sufficient data for and which we really need to focus on more. One thing that I can provide from this update is that the study quality is not necessarily improving with time. So this is a preliminary update, and really don't take this with or take this with a grain of salt, because things may change as we're still cleaning up the data set. But one of the things that we hypothesize is, well, as time progresses, researchers are understanding quality standards, and they may be improving the quality of their hazard studies, which unfortunately is not necessarily the case. And another thing that we hypothesized was, well, journal impact factor should predict the total quality score of these hazard studies. And indeed it does, but at an extremely low rate. So we have an R squared of 0.02 between the total quality score of the hazard study and the journal impact factor. This is for all time points, so it doesn't, there's a little bit of a, you have to take time into consideration as well. And so that's why I color coded this here. So you can see that we really need to get some better quality standards for journals, and just overall have a better understanding as a community of what it means to do quality research in this field. And that brings me to another point, which I'm sure everyone is very well aware of at this point, which is that microplastics is an extremely popular field, and science is coming out at a breakneck pace. Currently, we are estimated to have about 10 publications published per day on this topic, and that is a hockey stick curve. So we're still increasing the amount that are being published every day. So just a little bit of a history lesson, and then sort of taking a step back of like, where have we come in the past 20 years? In 2004, Richard Thompson published an article saying, titled "Lost at Sea, Where is All the Plastic?" Where they were looking at the production of synthetic fibers, or estimating it, and then figuring out how much is in seawater based on global monitoring. And they could only account for a very, very small amount of what's actually being produced and estimated to go into the environment. In 2017, Dr. Coleman's came out with a paper titled "All is Not Lost, Deriving a Top-Down Mass Budget of Plastic at Sea." Here, they showed with different modeling efforts that you can accurately predict and measure the amount of macroplastics and microplastics out in the ocean, and maybe close this gap of what goes into the ocean and what we can actually monitor. It's mass balance. But in 2024, it seems like we are lost in a new issue, which is a sea of information. Really, this is a data digestion and analysis issue, as well as a data quality issue, as I mentioned earlier. And that's something that I think that we can address through our community effort in the subcommittee. Last year, I wrote a brief essay about this and how we can get from research to where we need to be in regulations, boiled down to harmonization, standards, targeted studies, and open science. So check that out if you're interested in reading a little bit more about this topic. And really what I envision for going forward is that we're never going to get out of this issue of having too many papers and too much information, but maybe we can use some cutting edge technology like AI, shown here, as well as our community efforts to have a little bit of a perspective and not just be stuck in the wave. We can maybe be in this helicopter shown here. One of the ways that we can improve upon monitoring in California and elsewhere is by really being strategic about how we use different methods, using complementary approaches that get at different particle types that may be cheaper or are more rapid. And that's what Steve Barnett is going to be talking about later today, something that he's been working on actively with his technologies. And something like Steve's tool may fit in a framework that we've developed called the tiered monitoring framework. There's already a tiered monitoring framework that's been proposed for PFAS, where you go and you use a cheap method that's sort of a surrogate method for what you're getting at, something like total fluorine, and then save the more narrow methods looking at a smaller number of analytes, but more expensive for fewer samples like PFOA and PFOS. For microplastics, we could use something like Steve's tool, which you'll learn about later, to look for total particles in a sample, or something like Nile reds staining, something like that, and then figure out how many samples we need to actually apply different, more sophisticated methods to, like our current standardized methods. One of the methods that we are currently developing that may be at the very top of this pyramid would be a forensic fingerprinting tool that allows us to understand not only what type of plastic it is, but who made it. This is a really ambitious collaboration between Toronto Metropolitan University, Manchester Metropolitan, State Water Board, SQUIRP, SpectralWorks, Marks International. So we'll be providing some updates from this as we go forward. And of course, the huge elephant in the room, or maybe the very, very small elephant in the room, which is nanoplastics. Of course, everyone probably saw that article about nanoplastics in bottled water that came out a few weeks ago. And really the exciting bit of that article, for me at least, was not the fact that we discovered, yes, there's nanoplastics in bottled water. We had a good guess that there was, but rather they developed an analytical method that is relatively rapid compared to what we had before. And right now we can only get down to around 1 to 10 microns with our current standardized methods for spectroscopy. But this method that they developed in this recent paper can get much smaller down into well into the nano range. And this is really where we need to go in order to get a more comprehensive assessment of risk, especially when it comes to human health. So just a little bit of a brief overview of what we're doing also with the marine environment. We've got Senate Bill 1263, which required the State Water Board and the Ocean Protection Council to initiate a statewide microplastic strategy in 2022. And included in that is assessing the risks for ecosystems, standardizing methods, and using those methods to establish baseline occurrence data, figuring out the sources and pathways of microplastics into our marine environments, and then recommending source reduction strategies to assess impact the problem. So when it comes to getting baseline occurrence data and investigating sources and pathways, this is really our priority right now. And you'll be hearing from Dr. Diana Lin later today about how we're doing this with a bit more detail. But just how this relates to the subcommittee is this idea, this fit for purpose monitoring methods. Analogous to what I showed before, there's different methods for different particle types, and they're complementary to one another. And really, the driver for the information is going to determine what type of method that you're going to use. So, for instance, if you're trying to get an idea for human health impact, you're going to be looking in drinking water and food. to characterize exposure, and you're going to have very high technical requirements, likely looking at the very small particles, ideally nanoplastics. So this is a huge table with a lot of information. This is also included in that 2023 essay that I wrote in Environmental Science Advances. When it comes to occurrence data and where we're finding microplastics in the environment, we know that urban estuaries are a dominant pathway to the ocean. And the closer you are to cities, the more microplastics you have. Seems pretty obvious. Where humans are, plastic is. And this is a really cool study that came out of Narragansett Bay over in Rhode Island last year. And so we're using this information, we're looking to the literature to design our monitoring here in California. One of the major sources of microplastics in California and elsewhere are tire wear particles. These break when you're driving on the road and can get into waterways through stormwater. And investigating intervention countermeasures is one of the priorities of the Ocean Protection Council's plan. We know already that bioretention cells are fairly good at capturing microplastics from urban stormwater. So this is something that we'll also be investigating going forward. We also know that washing machines are a huge transport mechanism for microfibers, with about 7 kilotons estimated to enter California's environment every year from this pathway, most of it going into biosolids that could then be land applied to terrestrial environments. Sorry, 1.6 kilotons, not 7 kilotons, microfibers applied to California's lands via biosolids. This is something that we have to address holistically, thinking upstream about the textiles that are produced and sold, but also how we can capture them at the washing machines as well as in wastewater treatment plants. And we really should all be working together at this instead of just pointing fingers at each other, of course, a little cheeky meme that I made. So that's something that we can focus on moving forward as well, these intervention strategies. And we know washing machine filters are already really good at collecting microplastics, which can lower the amount that's discharged from wastewater treatment plants. So to end with one really big step back, we have been focusing mostly on plastic from a waste level. And under this problem frame, we're looking at we're looking at solutions that involve cleanups and better waste management. But really, we need to be thinking at all of the different problem frames in order to enact sets of solutions that are strategic and effective. And one of the highest problem frame proposed by Martin Wagner in this 2021 paper is a circular economy set of solutions that addresses the system problem frame. And this is something that California took on in a very ambitious way in 2022 with the passing of Senate Bill 54, Senator Ben Allen's bill, which requires products to meet certain recycling and composting requirements by different years, 30% by 2028, 65% by 2032, and also provides funding for monitoring, which is paid for by $5 billion collected over 10 years from industry to mitigate impacts. So a small portion of that goes towards research and funding, but we can leverage this for our efforts as well. And something that we want to just keep an eye on is what we're replacing plastics with. Under business as usual, we are currently using fossil fuels to generate plastics, greenhouse gas emissions, toxic chemicals. A regrettable alternative is that we just substitute fossil fuels as the feedstock for bio-based feedstocks like corn, and we're still making plastics, toxic chemicals, and resulting in biodiversity loss and soil depletion now, as opposed to greenhouse gas emissions to a large extent. So a sustainable alternative would be that we implement safer by design principles to reduce toxic chemicals in our products and ensure that we have renewable agriculture so that our bio-based feedstocks are actually good for the ecosystem and not eliminating biodiversity loss or eliminating biodiversity. So one last thing, analogous or complementary to the subcommittee are a lot of different tools that are already out there for doing research on microplastics. A lot of these are open source or open access, and there is an overwhelming amount of them. And so that's why I created the Plastiverse with some of my best friends, which is a very simple website. It's free. You can check it out. It's really right now a compilation of these different tools and a community hub for different topics on the field. So check that out. And this is something that I, again, believe to be complementary to the subcommittee. So I want to pause a bit and get your feedback. We've got a lot of experience under our belt at the subcommittee. We've accomplished quite a bit, as you've seen in our presentation, but we can scope where we want to go moving forward. And so I've just put together a really short survey using Google Forms. If you want to go and fill it out right now, that would really be helpful for all of us. It's just a couple of questions. So we can take a short little break and do that. And I'll drop the link for that in the chat right now. Let's see. And we'll get that going before we go to our next agenda item. Let's see. Sometimes copy pasta doesn't want to work, so you got to do it manually. Alrighty, so you might have to copy and paste that into your browser. Let's see if that works. Are folks seeing the form? Cool, alrighty.
Scott, could I ask a question?
Absolutely, yeah.
I was wondering about the SB 54, that recycling and composting thing. I don't know anything about it, so apologies if this is common knowledge. But it sounds like they're requiring like a component to be recyclable or compostable. What are the definitions of compostable? Is it like industrial composting? Is there any? I know that this probably could be a really, really long conversation, so maybe.
Yeah, I'm actually not sure. And it's not compostable. I should correct that. It's not actually compostable, but has to be verified to have been composted and recycled. So they have these independent producer responsibility organizations that go out and verify what is actually happening to the product at the end of life. And I don't know if we have anyone from CalRecycle here that's working on SB 54, but if we do, feel free to unmute and chime in.
That's super interesting. Thank you.
Yeah, we should certainly keep tabs on that and make sure that we're abreast of it. Maybe for one of the upcoming meetings, we can get an update from CalRecycle on what they're doing with that.
Yeah, that's a great idea.
Hey, Scott, I'll put the link in the chat. CalRecycle don't work on SB 54 directly, but I'm sure they'd love for you to. Well done, Paige, and I'm sure there's legs there. So nice to see you, Scott.
Oh yeah, thank you. Appreciate that.
Looks like Fred has a question.
Hi, yes, my name is Fred Briones. I'm the advisory board member for SB 54, representing disadvantaged communities. Hello, everyone. I'm calling in from Lodi, and we have our first advisory board member for SB 54 next week Friday. And that is a good question that you have, that compostables. And I think that's where everyone is kind of lacking some education going forward. I think that's probably something that we should look into, is to educate people into exactly what it means to be compostable and definitions. I know many tribes are in rural areas, so I'm getting a lot of questions also, like, what does this mean, compostable plastics? So maybe I could bring that up to the board and then have some more information at our next meeting for you guys. So thank you.
That'd be
great.
fantastic. Thank you so
Yeah.
much, Fred.
Terry?
Hi, everybody. Thanks. Great presentation, Scott. And it's good to see everybody here. I did post a question in the chat. I don't know if everybody could see it. I'm getting questions from member agencies and sub-agencies if we have resources and tools for them to develop for their websites. So like a frequently asked questions or a fact sheet. Of course, if those types of materials are being developed, and it would mean that those materials would need to be regularly updated because everything is moving so quickly. But for the monitoring for microplastics in drinking water, specifically a FAQ and a fact sheet would be super helpful so that we're providing the same information consistently to the public.
That's great, Terry. I hear you want to lead that effort.
You know what? I'll be happy to help out, of course. Yeah.
Thanks, Terry. Righty, so I'm going to let's see. Anyone else have anything to say? Otherwise, I'm gonna hand it over to our next guest speaker, and then after the guest speakers, we can look at what you all said from the survey and have a brief discussion about that. So Dr. Steve Barnett is going to be talking to us about microplastics identification and quantification using Raman and spectroscopy and optical microscopy. Steve runs Soar Optics. I believe he founded it, correct? And works in Sacramento. So I'll hand it over to Steve.
Great. Thanks so much, Scott. And can you folks see my screen?
Yep, that's great.
Okay, great. So thank you very much. I did want to tell you a bit about what we're doing in the microplastics area. It is something that is definitely still under development and in the early phases of development, but wanted to give you an idea of the rationale for why we're doing it, where we think it'll fit in to the microplastics monitoring regime. I wasn't sure if anyone was going to mention this, but Scott did. The recent paper with the stimulated Raman scattering microscopy of microplastics and nanoplastics. It's a great work. I mean, definitely have a look at it if you haven't seen it. One thing that was really nice is as Scott said, it's a rapid monitoring method where they quantified both microplastics and nanoplastics in a sample and demonstrated that the number of nanoplastics was far higher than microplastics, which I think intuitively many of us had always assumed, but it was actually nice to see that they came through with some real data. They with this method, they're providing the chemical information on all the particles that they're seeing because of the speed. But as much as this is great research and a great method, it's also a very expensive technique. It's a very complex technique. And so while I'm sure we'll see more and more papers come out of this, for practical, widespread, routine monitoring, I think it's a long way off to being implemented. So, but I just want to sort of mention that. So I think we all know that current California methods involve, for drinking water, filter 1,500 liters of water and then measure the size, shape, and chemical composition of each particle. So, and so your typical sample workflow is collect samples. I throw in a cleanup phase just because I generally have this slide for all types of water. that you're going to want to have a sample that has just water and microplastics in there. So if there's any kind of cleanup needed, it falls there. Then you have a separation, which is typically a filtration. Your microplastics are on a filter. You're doing your visual imaging, and then you're doing your chemical speciation with FTIR or Raman microscopy. So because of the time it takes for doing the FTIR and Raman, you typically need to do subsampling, where you're selecting a portion of the filter for the chemical characterization. So it's just a requirement. Otherwise, measurements of a full filter would take literally days in many cases. And so you might take a slice of a filter. There are many ideas for how to sample on a filter. This is just one typical one. And so you take a section and you hope that that's representative of what's on your filter. But it is also hope. And ideally, we'd like to get information from every particle on the filter, some sort of information. So what I've inserted in here is the same sample workflow, but I inserted an apply/define subsampling method to keep in mind that this subsampling component is a critical aspect of how good your quantification is for microplastics. So, so there are many challenges for quantification that, many of us, that I'm sure have been discussed and that are involved. There's the whole filtration aspect. And actually, Scott mentioned some real nice work from Bob's group at the University of Toronto, that it sounds like from his wording that it'll be implemented, either the loss of microplastics in filtration or the environmental contamination as part of filtration. And so there's been some nice work there. Drinking water is typically fairly straightforward. It's fairly clean water. But once you start looking at wastewater, then there is a need to look at what sort of cleanup methods and digestion methods need to be implemented and how that might impact the quantification for microplastics. I threw in a little bit about seawater, and then again, the whole subsampling. So this is actually from the EPA. This is an image of a sample that they were looking for microplastics on. This is on a filter. And if you look at this and you say, okay, where are the microplastics? Well, it turns out they're actually right there in those red circles. And that there are other inorganic solids that stay on the filter. And so using just visual microscopy and standard white light imaging isn't really going to give you need more than just doing that white light imaging. So when we think about, obviously the studies are coming out in terms of the microplastic impacts on human health. To a first approximation from the early days, we always assume that size, shape, and chemical composition of the microplastics were three of the important parameters, and that's what's come out from. That's what's led to some of the California documentation and recommendations that have come forward. There is a tiered approach, which again Scott mentioned, where for tier 1, you're primarily using optical microscopy to count the particles, get the size, get the shape. You're not doing chemical speciation. There is a tier 2 where there might be some sort of a simple speciation, whether it be organic or /inorganic or something of that sort. And then tier 3 is the more detailed chemical speciation, where you're getting the specific chemical structure that the FTIR and Raman microscopy gives you right now. So, and then just sort of a review of the history of plastic production and the different types, starting up with polypropylene and then going down from there. One area I'll throw in, I'll make a point on because I'll bring it up a little bit later, is the additives. But this actually gives us an idea of the types of plastics, the microplastics we're looking for. So with chemical composition, FTIR and Raman are the current methods, although there are some other mass spec methods. Scott mentioned that, and they're definitely out there. You typically will get a spectrum to provide the unique identification. FTIR, it's difficult to look below 10 microns, whereas Raman, you can ideally get down to about 1 micron, so you can look at those smaller microplastic particles. So, and as I mentioned, this is what gives you your tier 3 method of analysis. And so you get a spectrum, different chemical structures, different bonds show up in different regions, and the sum of bands in a spectrum is what's going to give you your unique identification. So for example, in a Raman spectra, this is polyethylene and polystyrene. You can just visually see that the spectra are very different, and these can be easily used for identifying what type of plastic it is. So in Raman microscopy, you're typically taking a Raman signal into a spectrograph, and then the light gets dispersed onto a CCD. So in essence, it's 1,024, very often 1,024 individual pixels, which essentially means individual detector elements. And where the lateral axis, the x-axis here, is your wavelength axis. And so it's in a spectrum, it's actually represented here across your CCD. So, and that's how you get your spectrum. So for doing Raman microscopy of microplastics, you're going to do your white light microscopy to give you your size and shape, and then Raman spectroscopy to do your chemical identification. So practically it looks like this. You'll have some sort of a Raman spectrometer. It might look like this. It might be bigger. You do your white light imaging to get your size and shape, and there's your tier 1 identification. Get a Raman spectrum. That's PET, and then do that for all your particles. And that's what gives you your tier 3 method for identification. So now, where we sort of come in is tied into the measurement speed, because if you look at a Raman spectrum, let's go back here. Right here, you can actually see there are certain peaks that are characteristic of the plastic, and there are many other areas where there is no peak. And Raman spectroscopy is great because it can identify pretty much any organic molecule. However, if we assume that we're looking at microplastics, there are only a small number of Raman scattering bands that you need to look at. So it's useful to identify that. Another aspect of doing Raman spectroscopy is you've got certain optical components, and especially an entrance slit that reduces the light that goes into the detector. It's required to get a good quality measurement, but it reduces your signal. And then each one of these peaks is actually spread out across 5, 10, 20 different pixels. It's what you need to get a spectral shape like this, but it also means that your signal to noise is lower when you spread it out across a number of detector elements. And so what we're doing is we're starting with the assumption you're looking for microplastics, okay? And we're limiting it to the top 6, 7, 8 classes of microplastics, polystyrene, polypropylene, PET, for example. And so then we only need to detect the Raman bands of those microplastics. So in doing that, we can use detectors that are optimized for each of those microplastics. That gives us a much quicker detection, and also allows us to do laser raster scanning. We haven't built it yet, but we expect it to be able to do laser raster scanning on the surface. So in a bit of a drawing, it looks like this. You have your microscope, your objective, your filter. You have in this case, I've just shown 2-point detectors. You've got your microplastic particles on the surface. Your Raman laser will come down to the surface, scan along the surface, reaches the first one. Light comes back, goes automatically to the polystyrene detector if it's a polystyrene band or particle, scans along the surface more. And this all occurs in real time. I'm stopping it for the point of describing it, but it's a continuous motion. Reaches the second particle, that's polyethylene. So, and then goes on from there. Practically what it looks like, this is actually a Raman system that we're actually getting this Raman system in our office/lab in the next couple months, about a month. But this is a Raman system that has a single point detector, and just gives you an idea of what it looks like when the Raman laser scans across the surface. And so this will pull the signal off in real time for a single Raman band. And what we're building up is a module to do multiple Raman bands simultaneously. But that's how fast you're scanning this. That's about an area of about 400 microns by 400 microns. And then from there, you just physically move your filter to cover the whole filter. So why do we want to do rapid detection? I mean, it's faster measurement. It has the potential to rapidly characterize most particles, not the unique identification, but at least the class of, is it polystyrene, is it polyethylene, that sort of thing. So, and what I'll get into in a minute is it allows you to focus on some of the more dangerous particles. So it has we expect it to provide a tier 2 characterization method where you're getting some chemical information. You're not getting the fully detailed information, but you're getting enough to at least classify each particle or the major particles. So question has always been how much faster is it? Depends on the number of particles, the size of the particles, the separation. But to give you an example of what this looks like, here are the Raman spectra of PET, PVC, and polystyrene. And again, a CCD-based system will acquire these full spectra, but a filtered system like ours can just look at small areas of the spectrum and use a point detector and filters to get the signal to say, this is PET, this is PVC, for example, that sort of thing. So in terms of what types of optical filters these are, so your Raman laser will be here if it's 785 nanometers. And then this is the wavelength axis. And so you see they're individual, these might be a little hard to see, but these are individual filters that only transmit the light for a specific wavelength range, which corresponds to a specific Raman band for each of the microplastics. So, and then this can get built up into in this case, a 3 microplastic system into a system like this, where simultaneously the Raman signal comes back, and then we can automatically and in real time detect the signal for the 3 microplastics. And then eventually the next phase from there is to build it up to the 7 or 8 microplastics that we'll do. Again, taking this and rendering it into 3 dimensions, it looks something like this, where you have your 3 detectors, your filters for each setup, that sort of thing. So looking at the band intensities that you'd expect, I mean, these are actually taking Raman spectra, integrating the bands and saying this is what it would look like if you combine the signals for all detectors for each microplastic. You'll be able to identify which type of microplastic it is. So, so how much faster do we expect it to be? So on the assumption that all the light from a given Raman band will fall on one detector, assuming we do laser raster scanning, we don't need a detector slit, so we're getting much more Raman light onto the detectors. We're figuring 40 to 50 times faster than traditional Raman spectroscopy. So, so we've started building things up. I wish I could say it's further along. We've got our sort of lab set up in here where we've got our laser, we've got the optics coming out with a microplastic here, and then our detector over here. So it's a much simpler setup than what you have in terms of full Raman spectrometer. And eventually there'll just be multiple detectors, multiple filters, and other optics that couple the light in. So I had this slide before where I talked about the microplastic impacts on health. I said size, shape, chemical composition. Well, we're all starting to realize that more and more the additives is a very key component. And what small molecules are associated with microplastics, whether it be that they were incorporated as part of the original production or small molecules that they've absorbed from the environment. And this is likely going to be dependent on the chemical composition of each microplastic. So there'll be some microplastics that are more likely to absorb toxic additives than others. And to determine the additives in a given microplastic particle, you do need the full spectral ID. You need a spectrometer. You need to acquire a full Raman spectrum. So what this means is that it would be nice to be able to say, and I always use polystyrene as the example, and I don't know, there are others in this field that are working on this much more than we are. If polystyrene happens to be the one type of microplastic that most commonly transports toxic additives into the human body, it would be nice to identify the polystyrene microplastics and then do a full spectral ID, a full Raman spectrum on each of those. And so what we're proposing and where we think this will play a role is that same sample workflow, but we're actually looking to modify the subsampling method. So I showed you the pie shape of subsampling on a filter, and other subsampling methods tend to use other methods based on spatial distribution of filters, but instead actually do a chemically defined subsampling where you define the subsampling algorithm based on the class of each particle. And you say, okay, again, polystyrene is the example. Let's say polystyrene is the most dangerous one. We do the rapid scan, find all the polystyrene particles, and then go back and do a Raman spectrum of those polystyrene particles. And so in that way, this type of rapid scanning module, a rapid scanning Raman system, can actually be a module on top of a full Raman microscope, where you've got your full Raman microscope, our module sits on top of it, so that you can do the rapid scan. And then once you've identified which particles you need a full Raman spectrum on, it hands off to the other full Raman spectrometer and allows you to do all this in a reasonable amount of time. So you're spending your time on the most dangerous particles. Taking it a bit more simplistically, this module will also be able to quickly say which particles are organic and which ones are inorganic. Similar to what was, I showed you the EPA slide, but we all know that everywhere there are many inorganic particles that if you're just using white light microscopy, you're not gonna be able to tell which ones are microplastics. So those are our ideas. That's where we're going, and that's what we're doing. I wish I could say we were further along than we are, but we're plugging along. But my one of the guys that works with us loves this, so I always told him I'm going to show it. And we're just working to make microplastics monitoring simpler, quicker, and hopefully more cost effective as well. So thank you very much.
Thank you, Steve. That was great. Wonderful overview of your instrument. Looks like Shelly has her hand up.
Thanks, Monica, and thank you, Steve, for your presentation. It was really interesting
Thanks.
to learn about that. I have some questions about just a few things that you said. The speed of the instrument, that's something that was so needed because we're looking at long-term monitoring. For agencies that don't have a team of volunteers, we're going to have to be working. So we definitely need high throughput and accurate systems. How does the speed compare to something like LDIR, which is, I think it's 3 to 5 minutes for the entire slide or filter?
Will probably be longer than LDIR, I expect. I mean, I think we've figured that it would be in the tens of minutes. So I think the advantage that we'll have is and correct me if I'm wrong, because I'm not sure about this, but I mean, with LDIR, you're still working in the mid-infrared wavelength region, and so getting down below 10 microns might be a little bit of a challenge. Whereas with Raman, I expect we'll be able to get down into the 1 to 3 micron range. So,
and then the other, that's great. The other thing with Raman is that it has this particularly hard time with carbon black, things that you find in tire wear products in particular. So, or things that have a lot of pigment to them. How does this technology do with that?
Well, I mean, the sad part is we can't beat physics, and if a Raman spectrometer can't see a Raman spectrum for carbon black or for the tires, I mean, we're not going to see it either. We will be able to tell. I mean, I talked about how the Raman intensities will vary for different microplastics. At the same time as well, if something is fluorescing, it'll also show up in our detectors just because every detector is going to give a high signal level. So unfortunately, we're not going to improve that probably. There are sometimes advantages signal-wise when you don't illuminate a material for a very long time. But I won't sit here and predict that we're going to get tire spectra through Raman. I don't know. It's something we'll have to try, but that's definitely a challenge.
Yeah, and it's also interesting thinking about pyrolysis GCMS which is also developed so you can get the full, including the chemical contaminants for 12 different polymers. So
yeah,
very interesting.
yeah.
Thank
Sure,
you.
thanks.
Excellent. Thanks. Brent. Brent, you're muted if you have a question.
Yeah, can you hear me now?
Yeah.
Great. Thanks, Steve. Good to connect with you again. In fact, as a side note, I may ping you for another presentation for an AWWA conference coming up here soon, so you can expect to hear from me.
Twist my arm.
My question, and I appreciate you at the beginning touching on sort of the elephant in the room, the Chian study that was just published a couple of weeks ago. In that study, among the notable things they detected was, and I'm not finished going through it yet, but as I understand it, the presence of polyamide, a lot of polyamide particles in the matrix, which they attribute potentially to the presence of RO being used to filter bottled water, which of course you connect the dots, makes a lot of sense. But in a situation like that, they didn't expect to find that degree of polyamide particles. But with your technique, they would have had to at least suspect that a priori to sort of program in the functionality to test for PA particles. So I guess I don't know if it's a question or just something I want you to comment on, to the degree to which you have to maybe have some sense of what you're looking for to employ your technique, and then maybe how you adapt if you're not sure.
The short answer is yes. I mean, there is a bit of this that we're at some, and we haven't finalized it. We have to say these are the entities, the plastics we're going to look for, or the materials we're going to look for. It probably makes sense for us to be looking for the amide bands. And I say that not even so much from this study, but I do a lot of work actually in the semiconductor industry as well, and in clean rooms, or what are supposed to be clean rooms, many times 20% of the contaminants are skin flakes, and so it wouldn't surprise me if we end up implementing but okay, so that covers the amide band. But you're right, if at some point some other molecule ends up being something that we need to detect for, I mean, there are a couple different ways that we potentially could do it, but it does at some point we are actually locking in these are the major microplastics we're looking for. So, and we have to hope that at least that gets us, and we're going to be doing that by surveying most of the important people in the industry once we get to that phase. We've already done that to some extent over the past couple of years, but we'll be doing it more aggressively over the next year. So yeah.
Great, thank you, and appreciate your presentation and your contribution to the field so far.
Thank you. Thanks.
Excellent. Should we move on to our next speaker, Dr. Diana Lin? And I think, Steve, there was a question for you in the chat. And so there are additional questions. We can put them in there. And maybe Steve can answer them.
Mm-hmm.
Hi, everyone. Can you see my screen and hear me?
Yep.
Okay, great. I'm so excited to be here. And I just want to apologize. I have a sick child sitting right next to me, so I'm sorry for the distractions. So I'm going to be providing an update on an ongoing project to develop a statewide plastics monitoring strategy that Scott Coffin mentioned before. Trying to move my screen. As this group probably knows, California Ocean Protection Council published the first statewide microplastic strategy last year, which includes two major tracks. Track 1 outlines available near-term strategies to reduce microplastic pollution, and Track 2, which is equally important, outlines critical science priority needed to inform future actions. And environmental monitoring is a major priority for Track 2. OPC funded 2 microplastic studies to support monitoring. The Southern California Coastal Water Research Project was funded to lead development of standardized field sampling methods, and SFEI was funded to support OPC in developing a statewide plastics monitoring strategy, which includes macro and microplastics. So today, I just wanted to share a brief introduction about this ongoing project with the goal of getting your engagement on this. The project team is led by the Ocean Protection Council, Caitlin Kalua, who is Deputy Director, and Christine Sir, a Water Quality Program Manager who recently joined OPC. And at SFEI, I am leading the project with my colleague, Tony Hale, and we're supported by Kaylee Patterson. OPC has outlined a vision to develop a statewide plastics monitoring network. And the main goals are to collect comparable and high quality scientific data of macro and microplastics in California environment to support management decisions and communication across the state to protect and improve coastal and ocean water quality. The vision is to emphasize management and protection of aquatic ecosystems and human uses of those ecosystems. And the vision is to inform and identify partners to establish a coordinated plastics monitoring network across federal, state, local, tribal, and regional monitoring programs and includes citizen science. And we also expect the main monitoring to be led by the State Water Board. The envisioned monitoring strategy will identify consistent goals and monitoring objectives across various programs and partners and help guide partners to implement consistent and coordinated plastics monitoring, data collection, and reporting for microplastics in ambient waters across the state. And this effort will also guide and prioritize future investments in plastics monitoring and management approaches. And there are clear advantages to having a statewide plan. It would help optimize effort by reducing duplication, increase interoperability and comparability, provide progress tracking towards state goals, and enhance innovation by sharing best state and science approaches across geographies. So we are in the early stages of the project, which requires us to first define the scope of the project, starting with prioritizing project goals and objectives. We are hosting focus meetings with regulators, stakeholders, and community groups and the public, as well as convening a technical advisory group for science and topic experts. And with continued guidance from this technical advisory group and state advisory group and the Ocean Protection Council, we will be developing a monitoring strategy. And then we're expecting to have a draft plan in the form of a report to share publicly in 2025. And we will continue to have focus meetings to get feedback and have opportunity to provide written comment period, and then have a final monitoring strategy. So as I mentioned, the first step is to first identify and prioritize the main goals and objectives for this plastics monitoring strategy. This requires us to define what are the priority management questions we're trying to address. So I've identified 5 broad overarching management questions that cover the potential topics that the statewide plastics monitoring strategy would cover. And again, this is just my first draft proposal, and part of what I'm doing in this first stage of engagement is to clarify with various groups if these are the priority questions and which of these are the most important. So just going through these, the first one, what are levels of macro and microplastics in different aquatic ecosystems? Are levels of plastics at levels that may impact aquatic ecosystems? What are the major sources and pathways? Are plastic levels in the environment changing over time? Can we track trends? And are plastics at levels that may impact human health and welfare? So for today, if there is time, I was hoping to get some initial input from you all, but also noting that we are going to have a more formal public request for information that will be posted on our website to gather input from everyone. So some initial questions for discussion are, which of the management questions I posed in the previous slide are the highest priority to address? Are there specific types of plastics, ecosystems, or locations that should be prioritized for monitoring, and why? Do you have any planned plastics monitoring that should be incorporated in a statewide strategy? Or is there any other feedback you'd want to share as we kind of develop this monitoring strategy? So I just wanted to introduce this project to you all and provide the opportunities to stay engaged. We have a project website that has some initial information, and we will continue to use this website to post information and updates, as well as a request for information soon. Other ways to stay engaged, you can join OPC's various listers and Google group, or you can contact me directly. And with that, I'm happy to answer any questions or get some input.
Great. Thank you, Diana. Do you want to put up the slide that you're specifically requesting for feedback on?
Yeah, I can start here, and then I can also go to the previous slide here if there are questions specific to this or comments.
Any feedback for Diana? I'm curious about the second question. Do you have a planned plastics monitoring that should be incorporated? What are you looking for in that question?
Well, this plastics monitoring strategy includes both macro and micro. And so if there are groups or researchers that are doing monitoring in California, I think we very much want to be aware of that and kind of incorporate that.
Great. I know that there is some monitoring happening in the Tahoe Basin that might be relevant for this. So yeah, whenever, however is easier for, we're kind of summarizing that right now as another group I'm on. And so I'll make sure I share that information with you once we have it summarized.
Okay, that's perfect. Thank you.
Great. And we have a hand raised from Fred.
Hi, hello, doctor. Thank you for your presentation. That was very informative. And I'd like to just add some input from a tribal perspective, who's our community. We depend on traditional food gathering, specifically from the ocean, in which we harvest seaweed. And we're so concerned of every little piece of sand, seashell, or debris in our seaweed. And I think it would be really helpful if somehow we could help you, the tribes, the Pomos, who harvest seaweed from San Francisco all the way up to Fort Bragg, and some way connect in your monitoring, because right now we harvest seaweed. We've been doing that for a long time now, for thousands of years. And one of the things that we have to say is that our beaches and our oceans, compared to others in Northern California, it is very clean right now. There's no plastic at all. So to have a lot of eyes out there, especially tribal people, we're always out there foraging along the coast. So we'd like to help you in your study here. And then also, one more thing that I'd like to mention is that I am also a representative for the Water Quality Monitoring Council. And we had a meeting like a week ago or a month ago, and we had a really good presentation from the Ocean Protection Council. And they mentioned how the microplastics now are traveling from the ocean to the Sierra snowpack, which now is the drinking water supply for the city of Lodi, where I live. But then also that water supply from the Sierra goes to San Diego. So monitoring that in between there somehow, I think really needs to, from Northern California to Southern California, those microplastics in the aqueduct specifically should be have some attention. Those are just my thoughts, but I look forward to participating in your work. Thank you.
Thank you. And thanks for that feedback. And that would be great to connect.
Any other questions or feedback?
Ollie wants to say hi, and then I will turn off my, hey, do you want to come here? You want to say hi? Oh, that's okay. He's too shy.
Thank you so much, Diana. This is great, great update.
So I think the next thing on this agenda is a bio break, but if anyone has to go, I want to make sure that you see the link in the chat for our contact list for the Microplastics Monitoring Playbook work group. We're going to be giving a major update after the bio break. And so if you're not able to stay, at least make sure we have your contact information, but I hope you can stay. So Monica, did you want to say 5 minutes from now, like 12:33?
Yeah, yeah, I think a bio break would be great. So let's do that.
Okay, all right.
Sorry.
I'm gonna run down the hall. Okay.
Yeah.
Okay, thanks all. So back in 5.
Thanks, everyone. And if you're still at your computer, we would love for you to fill out this form, the Google form for getting feedback. Currently, we only have 35 responses, so just take a couple minutes to do that.
Shall I go ahead and share the opening slide? Get us warmed up.
Sounds great. Thanks, Shelly. Oh, Shelly, are you presenting? Because you're on mute.
Oh, okay. No, I'm unmuted. Sorry. Should I begin? So welcome back, everyone. This portion of the Microplastics Subcommittee meeting will focus on an update from the Microplastics Monitoring Playbook, or MPMP workgroup. It's also known as the Sampling and Analysis Playbook, but we call it the Monitoring Playbook because it incorporates a lot more, including reporting and analysis, data analysis, all kinds of things. So kind of thinking full picture. So for our update today, we're going to give a brief recap of the playbook. We'll talk about the sign-up list, which I put in the chat. Another Google form for you to fill out was just your contact information and how you'd like to be interested in participating in the playbook process, including just, I want to listen and learn. That's fine too. So please make sure you sign up for that so we can have your contact information separate from the State Water Board listserv, because we may need to kind of contact you outside of the listserv, which we don't have access to use for contact. So, and then we'll talk about next steps. So as a recap, the Microplastics Monitoring Playbook is a living document, and it's based on the best available science and lessons learned. Instead of creating something brand new, there is a lot that we can take and kind of give the best guidance that we can, best professional judgment, and user-friendly tips. The other tenet of the playbook is that it's question-driven, evidence-based, and statistically rigorous. That's very important and hard to do with microplastics research. And so we're going to kind of bring a lot of that together that you may not have seen anywhere else. And that's because of the problem of how long it takes to do these analyses. And when you shrink your sample size and your number of samples and you're subsampling, you're losing data quality. And so we're going to be following US EPA and other federal agencies' guidance on data quality objectives and how to really define what you need to be distinguishing between your different treatments and how to achieve that statistical rigor that is often missing in microplastics research and monitoring. So Shelly Moore, Harry Allen, and I have been working on the playbook, and we really want your input and your some more feedback into the playbook. We've got a 45-page document right now. So I'm going to kind of briefly go over what the sections are and how you can get involved. And so here's just a snapshot of the table of contents. And you can see we have some major sections, including, why we need the playbook. Well, Scott gave a great intro for that. We want the quality of microplastic studies to increase, not decrease, right? And how do you sort through all of this information, some of which is conflicting with each other? So you need to be able to see, methods and studies and be able to critically know whether it's something that you want to follow, or and think about the sample design, the study design, and how you will do that. And go into the different collection analysis, including prep. There'll be a section on the ELAB certification that the Moore Institute has gone through, and also reporting. So lots of great stuff. There's going to be examples of how to do your study design calculations, sample data templates, all kinds of wonderful resources. And so to get involved, before I do that, I don't want to have to switch in and out of the presentation. So I was going to show you a live kind of snapshot of what we have right now in the living document, which is on Google Drive. We've got this participation sign up list. Now, we want to know, do you want to lead one of those sections that I just kind of reviewed of the playbook? Or do you want to maybe just focus on graphics? Or do you just want to sit back and watch and listen and learn? That's fine. We just want to know what level you're looking at, and what kind of sections you're interested in. So the survey also, you can actually give input into what sections you're interested in. So just some brief updates beyond the playbook. We've heard about these great and up and coming methods. We've heard about the tiered monitoring programs, and really exciting. I've been talking about this for a couple of years now. The ASTM has finally kind of ratified their pyrolysis GCMS method, which allows for rapid analysis. Within 20 minutes, you have your full sample, and including 12 different microplastics polymers and the contaminants on the particles, depending on how you've set up your the spectra. And so that's very exciting. It's going to be published soon on the ASTM website, and you'll have access to that if you're an ASTM member. And if not, it's the same price as membership. It's like $70, and you've got the method, but why not join? And then you have thousands of methods. And we'll be using that framework in various research studies, and also the playbook will kind of run through it a little bit too. And then for our next work group meeting, we're going to have Harry Allen give a talk about repeatable measurements and how to do that with microplastics. So very exciting. And that's all I have in this presentation. Let me switch gears to the see if I can do this. The playbook itself. Sorry. Okay, so we've got the playbook here, and you can just kind of see that the sections, we've got a lot filled in. There's certain chapters that are another separate document that we'll just be putting it in. Things like sample representation. That's a whole other document that we'll be putting in. Same with ASTM methods and the various methods that the State Water Board has already put through for FTIR and Raman. Best user tips for those from experts who have used the methods a lot. Tips about getting ELAB certified, all kind of in one place. So that is just running through lots of great stuff, and we'll also have links to the Zotero library, and which if you're a member of the work group, you have access to not just to the references, but the actual publications themselves are actually stored in the library, so you can have access to those as long as you're kind of a working member of the work group. So anyway, that's all I have. I'll post the link again to our survey just to get your contact info and how you most want to participate with the work group. So that's all I have. Thanks a lot. Any questions? And Shelly, if I missed anything, please chime in.
I'm really impressed with the breadth of the document so far. It covers a lot, and that's really, really great. I think it's going to be really helpful.
We're really excited, and Scott just gave us such a great intro with the, the quality, and that, that's, all of these microplastic studies that are coming out, they're not going to help inform us unless we really nail this down with the quality. So, and there's not really anyone that's really focused on that. We're in a good spot to do that, and especially with drinking water and biosolids are kind of our two focus areas for this year.
Yeah, I think that's such an exciting opportunity that we have here at the subcommittee and in California in general to really bring the level of quality up in the field and then set some precedent for reporting and analysis. Thanks so much, Shelly. If anyone has any questions, yeah, go ahead, raise your hand, unmute. Go ahead, Max.
Yeah, hey Scott and Shelly, everyone. I just responded to the survey, and because of my work at CDC, we have some limitations in participating in a better way with efforts like you are doing. And I think one of the questions is if you are willing to lead, a section of the playbook. I was wondering if, it's possible to be among the group or the team that will be working on a section. As you know, one person cannot do all. I think will be a need to collaborate with colleagues. If that's the case, I'm willing to be part of a team that's writing a section. And the other thing that sometimes we are, we have some limitations or requirements to fulfill here at the CDC is, anything that we write or we are part of, we have to clear internally. And sometimes the clearance process here takes a while, and that can slow down, the process that you are accustomed to. So those are some things that I wanted to share with you. I'm currently leading a systematic review on microplastics in water and potential health effects. And what you just mentioned about the quality, that's something that we are taking into account. We selected more than 7,000. We had a library of more than 7,000 papers, and we reduced all the way to 108 because of quality assurance, quality assessment of the papers. So, hopefully by the middle of this year, we'll be sharing that paper. That paper will be published, and we'll be able to share with everyone. But that's what I wanted to say. I found that part of the survey a little limiting, but I don't know if you are open to, like, whoever is leading a section, can organize a team and somebody can be part of that team.
Absolutely. Great question, Max. And yes, we'd love to have you participate. We can talk about the details, offline, and I think we can work things out. So the way that if you see in the Google form, it'll specify sections. If you want to specify, you can just focus on that section. or you can click multiple sections. And then we're thinking it's going to be a very collaborative, interactive approach where we even have working sessions where it won't be a meeting of presentations. We'll actually be actively working on the documents during the working session. So, Monica shared some really great guidance on, just how authorship would go, and we can incorporate, make it workable for the work group and as well as your employer. So I think that would all work well. Just make sure that we have your contact info and indicate kind of any particulars. There's a place for comments if you want to add information. While I have my mic open, I just want to answer a couple of other questions that are in the chat. So someone's asking for the link. There's no public link right now to the entire document. It's a draft document, and it'll be accessible to those who are in different working sections that are focused on that section. They'll be working with those sections, and we'll bring it all together. There's no final as far as the completion of the playbook. It's a living document, so it's never going to be completely, set in stone, but it's this year that we're definitely going to have things completed for drinking water community and biosolids. We're looking to have that done this year, and we're very close. So we just need additional leaders to take on some sections, and this can be working groups, not just like you're on the hook to do stuff. So just wanted to make that clear. Another question was, I think that maybe people could use the link to the Google Drive, Scott. If you could put that in, I'd had some questions for that, and just making sure that everyone has access. I know you put it in the meeting invite, but that might help. And so I hope that answers some of the questions. Thanks all.
Let's see, we did have one comment from Nick Martirano in the chat about reaching out to Rebecca Greenwood and Tyne Lowe, the water boards who work on the recycled water policy, which includes a section on emerging contaminants and method validation. So we might be able to borrow some of that template for our efforts for microplastics. Thanks, Nick, for
Scott, I've noticed that it seems the Google Drive folder, now you need to request access. Is that how it should be?
Boy, I will update that. Yeah,
Cool.
apologies for that. Cool. So, unless we have any more things people want to discuss, I just wanted to give everyone a brief preview of the survey that we sent out in this meeting. We got 44 responses, so if you want to participate in this, there's still time to do it. Drop the link in the chat again, but just to give you all a brief preview of what we got from today's survey. Let's see here. So in terms of affiliation, a third is from utilities. I'm assuming mostly drinking water. And then 18% is from state agencies. And then we have what seems to be fairly equal representation for the rest of the pie from all these different categories: federal agency, joint power authority, tribes, non-government organizations, industry, consulting. It's pretty incredible that how many different categories of folks that we have in this meeting. It's really exciting. And then let's see. In terms of geographic location, it seems like almost everyone is from California. Then we've got just a couple of people from outside of the US, or maybe just one. and 4 from outside of California that responded. In terms of matrices that we're working on or thinking about, drinking water is the vast majority of the folks that filled out the survey, so 65%, followed by wastewater, stormwater, ambient water, air, or sorry, soil, and then air, with just one person working on these other miscellaneous ones. We got snowpack in there. That's awesome. Which topics are you most interested in discussing / learning more about this year? And here we have quite a lot of different options that people chose. The biggest ones are sample collection, extraction, and data analysis and reporting. So that's really what we're going to be working on with this playbook. And then about half of respondents mentioned instrumentation and devices. So learning more about things like what we heard about from Dr. Steve Barnett, some innovative analytical methods or instrumentation, Yidian Liu from last meetings talking about sampling, that sort of thing. So that's really exciting. I think this might be a good venue for different entrepreneurs to get out there and talk about their innovations. Study design, risk assessment, risk and hazard assessment, communication tools and strategies, with just a few people interested in talking more about these plastic alternatives, countermeasures like treatment BMPs and cleanups, and best available treatment techs to remove microplastics from drinking water, which would fold under transport countermeasures. So what is your matrix of greatest interest for 2024? As mentioned earlier, it looks like everyone is really interested in drinking water, or the majority of people here. But the other matrices seem to also have sort of an even split, with stormwater and ambient waters coming up on top. So that makes a lot of sense. That falls in line with where our priorities are with the statewide microplastic strategy from OPC. And then, yeah, we've got a couple of responses of people talking about the work group subcommittees. So yeah, thanks everyone for filling this out. If you would like your voice to be heard on this, there's still time to fill it out. We'll leave this open for a little while, next week or so. So take your time if you didn't get a chance to do it during this meeting.
Thanks, Scott. That's really helpful to see. We're basically still on track and where the interest lies. It's really helpful.
Yeah, totally. Thanks everyone for participating.
Now we just need your contact info for the other one. I'll put that in the comments one more time.
Alrighty, well, last chance for anyone to provide any updates, questions, open forum really for anyone at this point. Go ahead and unmute or type it in the chat. Yeah, go ahead, Jessica.
Hey there. I apologize. I think this may have already been said, but I did have to step out for a minute. Regarding phase 1 of the source water monitoring, when was the expected timeline for that to begin? Or was that said?
So we're anticipating the sampling training will occur around fall of this year. And once the sampling training is done and we have the methods for sampling up online, then we'll issue monitoring orders to those 28 systems for there'll be at least a 6-month delay between the monitoring orders being issued and when monitoring will first be required. So think early 2025 for when samples will be required at the earliest.
Awesome. Thank you so much.
Thanks for your question, Jessica. Yeah, go ahead, John.
Can you hear me okay?
Yeah.
Hi. My name is John. For folks who don't know me, I'm the co-chair, one of the co-chairs for CASCA's monitoring and science. I put in the chat when Steve was talking about the Columbia group. They're working on, well, they developed a method to look into nanoplastics. It's kind of like the frontier of the microplastics issue. So I'm actually gonna invite them to talk about their research on the next monitoring and science subcommittee meeting call that's on February 13. I just want to say that, you know, for our issue, we focus on all things stormwater. So microplastics is one of the priority issues for Casca. So if folks are interested in joining the call, please let me know. I can share with you the invite. And I happen to actually know the PI from Columbia. He's a good friend of mine.
Great. Would you mind putting your email in the chat so people can contact you for that information? Thanks.
Thanks, John.
Thank you.
Alrighty, so one last thing. I'll send an email out about this as well, but you can go ahead and mark your calendars right now for our next meeting, which is going to be on April 11th from 1 to 3 p.m. And again, I'll send a calendar invite and email for everyone as well.
Thanks, Scott.
Okay, well, thank you everyone for attending. Really fun meeting today and looking forward to the work ahead.
And thank you to our speakers. It was great.
Thanks, everyone.
Thank you, everyone.
Thank you.
Great to see everyone.